In the last class, we are discussing about the properties of DFT. Of DFT. So, in the continuation, the fourth property is multiplication of two DFTs and circular convolution. Circular convolution. If x1 in n is a sequence and its n point DFT is x1k, x2n is a sequence whose n point DFT is x2k, then if we multiply these two DFTs, if we multiply x1k multiply by x2k, then this is the DFT of circular convolution of these two sequences. x1n n point circular convolution of x2n. Means multiplication in frequency domain is equivalent to circular convolution of sequences in time domain, or circular convolution of two sequences in time domain is equivalent to multiplication of their DFTs. Here we have this notation. Here this notation is n point circular convolution. Till now we have learned about linear convolution. In the initial classes we have done the linear convolution. Here a new convolution is introduced which is called circular convolution and represented by this n in the circle, n point circular convolution of x1 and x2n. First do proof of this property, then we go to the some example of circular convolution and its applications. So let's have proof of this circular convolution. Let x3k is equal to x1k into x2k. This is the multiplication of two DFTs. Then I DFT of x3k, I DFT of x3k. Let x3 n has n point DFT x3k. Then the I DFT of x3k will be from the formula. Let us denote time by m. x3m is equal to sigma 1 upon n sigma k is equal to 0 to n minus 1 x3k wn minus kn. This is the minus km. We have denoted time by m here. So it is minus k m. This x3k can be written as x1k into x2k wn minus k, where x1k is the DFT of x1n and x2k is the DFT of x1k is the DFT of x1n and x2k is DFT of x2n. So we can write here 1 upon n sigma k is equal to 0 to n minus 1. x1k can be written as sigma n is equal to 0 to n minus 1 x1n wnk n point DFT of a sequence x1n. x2k can be written as sigma L is equal to 0 to n minus 1 x2n wnk into wn minus km. So 1 upon n sigma sorry, there is some problem in my board. I think I should go for the new board. What happened here? Sigma n is equal to 0 to n minus 1 x1n sigma L is equal to 0 to n minus 1 x2n. So all the terms which has k are sum to one point. Sigma k is equal to 0 to n minus 1. This term has k, this term has k, this term has k. So let us take all three together. wn minus k m minus this is L here. So minus k m minus n minus L first summation has all the n term, second summation has all the this is L, all the L term. This is the x1k, it is the DFT of x1n, x1 e to the power x1n wnkn. X2k is the DFT of x2n. Here we have changed the notation of time from n to L into w and km. So we have arranged all the n term here, all the l term here, and all the k terms here. Sigma k is equal to 0 to n minus 1, wn minus k, m minus n minus l here. Now, let us take third term. Let us take third term, sigma k is equal to 0 to n minus 1, wn minus k, m minus n minus l. What is this term? This is wk is equal to 0 to n minus 1. Wn can be e की power minus j 2 pi by n minus minus plus into k m minus n minus l. Let this term e की power j 2 pi by n m minus n minus l is equal to a. This term is a. So this summation can be written as sigma k is equal to 0 to n minus 1 a की power k. This is the sum of finite series. This is sum of finite series. So what will the summation? 1 minus common ratio की power total number of term from 0 to n minus 1 number of terms n. So 1 minus a की power n upon 1 minus a when a is not equal to 1. When a is equal to 1, so this is 1 की power k, sigma 1 की power k from 0 to n minus 1, 1 plus 1 plus 1 up to n is n when a is equal. This is the summation of this term. Sigma, this term, sigma k is equal to 0 to n minus 1, wn minus k, m minus n minus l. The summation is this. Now, what is the value of a की power n? Here, a is e की power j 2 pi by n m minus n minus l. So what is the value of a की power n? E की power j 2 pi by n m minus n minus l into n, a की power n. N is cancelled by n. M is integer, n is integer, and l is also integer. So m minus n minus l is also a integer quantity. 2 pi times integer quantity. Cos 2 pi plus j sin 2 pi. This is 1. So when a की power n is 1, so 1 minus a की power n is 0. That means when a is not equal to 1, this term is always 0. When a is not equal to 1, a की power n is equal to 1, so 1 minus a की power is equal to 0. Means when a is not equal to 1, this term is always 0. Or when a is equal to 1, only this left. Means sigma k is equal to 0 to n minus 1 0 to n minus 1 a की power k. This has value n when m minus n minus l. This term when a is equal to 1 and a is equal to 1 when this is the multiple of capital N. A is equal to 1 when this is the multiple of capital N, only when a becomes 1. So when m minus n minus l will be some multiple p times capital N, where p a integer. and it is 0 otherwise. Look here, a की power n is always 1, means this term is 0. 1 minus a की power is 0. This is always 0 when a is not equal to 1. But when a is equal to 1, a is equal to 1 when this quantity is a integer multiple of capital N. In that case, n is cancelled by n. When in here, if m minus n minus l is equal to multiple of capital N, then n is cancelled by n, and a is equal to e to the power j 2 pi times p, 2 pi p. This will be, a will be e की power minus j 2 pi by n into pn, when n, this term is multiple of capital N. So this term will be cos 2 pi p minus j sin 2 pi p. Cos 2 pi p is 1, sin 2 pi p is 0. So a is equal to 1 when this quantity is a integer multiple of capital N. So when this quantity is a integer multiple of capital N, then this is n, otherwise 0. Or we can write m minus n minus pn m minus n minus pn is equal to L. And what is this? M minus n minus pn. This is m minus n periodic with period capital N quantity, means L can be written as m minus n modulo capital N. Therefore, this x3m can be written as 1 upon n sigma n is equal to 0 to n minus 1 x1n and the second L is equal to this, so into L is replaced by m minus n modulo n, and the third term, this is first term, L is replaced by n minus n modulo n, and third term is n, capital N. The summation, this summation is capital N. Therefore, this is into capital N. N is cancelled by this n. Therefore, x3m is sigma n is equal to 0 to n minus 1 x1n x2 of m minus n modulo n. This is the circular convolution of two sequences x1n and x2n. Means multiplication of two DFTs are equivalent to circular convolution of the sequences in time domain. Multiplication of two DFT is equivalent to circular convolution of the sequences in time domain. Let us do one example. Let us do one example. Find the 4-point circular convolution of sequences x1n is 1 2 1 2 and x2n is 1 2 3 4. We have two sequences. We have to find the circular convolution of these two sequences. So circular convolution can be written as, of the two sequences, x1n 4 point, this is 4-point circular convolution, let it is x3n. We have to find the 4-point circular convolution of these two sequences. So in formula term, we have x3m is equal to sigma n is equal to 0 to n minus 1 x1n x2 of m minus n modulo n. N is here n is 4-point circular convolution, n is 4 here, so we can write this equation as x3m is equal to sigma n is equal to 0 to 3, n is 4 here, x1n x2 of m minus n modulo 4. Means at m is equal to 0. At m is equal to 0, we have first point of circular convolution x30. x30 is sigma n is equal to 0 to 3 x1n x2 of minus n modulo 4. This is the first point of the circular convolution. So we have x1n. Let us do on the circle here. It is circular convolution. All the operations we do on the circle here. So this is your first x1n. We have 4 points here. This is your positive direction. x1n is 1 2 1 2. This is your second x2n. This is your positive direction, and the second quantity is 1 2 3 4. And we have to find the x1n multiplied by x2 of minus n, means circular reversal of x2n. What will be the circular reversal of x2n? The circular reversal of x2n is x2 of minus n modulo 4. This is your circular reversal of x2 of minus n modulo 4. So what we do in the circular reversal? We put the sequence in the reverse direction and read in the positive direction. So we put 1 2 3 4. So then the circular reversal of x2n will be 1 4 3 2. So for x30, this multiplied by this multiplied by this, point by point multiplication, and all the points are summed here. Means x10 x2 of minus 0 plus x11 x2 of minus 1 plus x12 x2 of minus 2 plus x13 x2 of minus 3. These 2 points are point by point multiplied then summed. Means x30 will be this 1 multiplied by 1 means 1 plus 4 multiplied by 2. The second quantity is 4 multiplied by 2 means 8 plus 1 multiplied by 3 plus 3 plus 2 multiplied by 2 4. 2 multiplied by 4, so 8 4 12 16. This will be 16. Then comes to next point, x3 of 1. This is sigma n is equal to 0 to 3 x1 3 x1 n x2 of n is equal to 1 here, m is equal to 1 here, so 1 minus n modulo 4. So x1 is, so this is your x1n positive direction, this is 1 2 1 2, and the second will be x2 of 1 minus n modulo 4 means x2 of minus n is shifted by 1. x2 of minus n is shifted by 1 unit. Shifting will be in which direction? Positive or negative direction? Shifting will be here, positive or negative direction. Take it similar to your linear convolution, linear shifting. When x2 of n minus 1 will be in the positive direction. When x2 of n is here and we have to find the x2 of n minus 1, then the shifting will be in the positive direction. Similarly, when x2 of n plus 1, shifting will be in the negative direction. Similarly, the reverse operation is with the x2 of minus 1. x2 of minus n plus 1, shifting will be right direction, positive direction, and x2 of minus n minus 1, shifting will be in the negative direction. So here the shifting will be in the positive direction. So this sequence is shifted by 1 unit. 1 comes to here, 4 comes to here, 3 comes to here, 2 comes to here. So here 1 comes to here, 4 3 2. These all are shifted by unit. This comes to here, this comes to here, this comes to here, and this comes to here. Shifting by 1 unit in the positive direction, since all the shifting operation which is done on the x2 of n, the reverse operation is done on the x2 of minus n. x2 of minus n plus 1, the shifting will be in the positive direction. What is the value of x3 1? This 2 multiplied by 1, this is 2 plus 1 multiplied by 2, so 2 plus 4 multiplied by 1 and 3 multiplied by 2, this is 14. Similarly, the value of x32 sigma n is equal to 0 to 3 x1n x2 of 2 minus n modulo 4 means this, there is a x2n of, this is shifted by 2 unit. Here the shifting 1 unit, it is again shifted by 1 unit, then x2 of 2 minus n. So we have x2 of 2 minus n modulo 4, this is your positive direction, So now this again shifted. 2 comes to here, 1 comes to here, this 4 comes to here, and 3 comes to here. So what value of x to n? This multiplied by this means 3 plus 4 plus 1 plus 8, 16. X32 will comes to 16. Then again, next value, x3 of 3. Sigma n is equal to 0 to 3, x1n, x2 of 3 minus n modulo 4. So x1n is positive direction, it is 1 2 1 2. x2 of 3 minus n modulo 4. So this is your x2 of 2 minus n. If you shift 1 again by 1, then it will be x2 of 3 minus n. So by shifting, this 4 comes to here, this 3 comes to here, 2 comes to here, 1 comes to here. Then x3 and x3 will be
14.
x3 will be 16. 4
14.
6 plus 2 plus 2, 14. 4 plus 6 plus 2 plus 2 is 14. So our circular convolution will be x3n will be, first is x30 will be 16, 14, then again 16, then x33 will be 4. This is the circular convolution of two sequences, 4-point circular convolution. For 4-point circular convolution, we have 4 output points. For 4-point circular convolution, we have 4 output points. The output points are 16, 14, 16, 14. This is the circular convolution of two sequences. Oh. Now, this is the time domain method. We can find the circular convolution by directly using the formula x3m is equal to sigma n is equal to 0 to n minus 1 x1n x2 of m minus n modulo 4. However, convolution in time domain is the time domain formula. Sir, however, convolution in time domain is equivalent to multiplication in frequency domain, means x1n n point circular convolution x2n is equivalent to multiplication of their DFTs. So either you do this by the formula this, or you can first find x1k, then you find x2k, then by using IDFT, you can find the convolution of two sequences. So we can first find the DFT of first sequence, then we find the DFT of second sequence, then in the third step we do IDFT of, then we multiply these two, and then finding the IDFT will give you the circular convolution of these two sequences. So let us do the frequency domain method. For the same question as given in previous example, we have two sequences. X1n is equal to 1 2 1 2, and the second sequence is x2n is equal to 1 2 3 4. What we do? We first find the DFT of first sequence. Let us do with matrix method. So by matrix method, the convolution of x1n can write x10, x11, x12, x13 is equal to W4 matrix. W4 will be 1 1 1 1. We have already find this. 1 minus j minus 1j, then 1 minus 1 1 minus 1, then the fourth quantity 1 j minus 1 minus j, then put input 1 2 1 2. Multiplication of these two provides the x1k, x10, x11, x12, x13. So let us multiply this. So first 1 plus 2 plus 1 plus 2, first will be 6, second will be 1 minus 2j minus 1 plus 2j, these are cancelled, quantity will be 0. In the third, 1 minus 2 plus 1 minus 2, quantity is again 0. 1 minus 2, 1 minus 2, minus 4 plus 2, it's minus 2. And the fourth will be 1 minus plus 2j minus 1 minus 2j. Summation is 0. Similarly, we can find the DFT of x2n. The DFT of x2n is, so we have x1k is equal to 60 minus 20. Similarly, x2k, so x20, x21, x22, x23, put it in the matrix form. Then wn matrix 1 1 1 1 1 minus j minus 1j, 1 minus 1 1 minus 1, 1 j minus 1 minus j. Then input 1 2 3 4. What is the value of this? Give x20. What is x20? What will be x20? 10. What will be x21? x21, 1 into 1 minus 2j minus 3 plus 4j. This is minus 2
minus 2 minus
plus
2j,
2j plus 2j. Third quantity will be
minus 2.
It is minus 2.
0
And the minus 2. 1 minus 2 plus 3 minus 4 is minus 2. And the fourth quantity will be 1 plus 2j minus 3 minus 4j.
Minus 2
2
minus 4
minus 2 minus 2j is the second quantity. So x2k will be 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Then in the next step is multiplication of these two. So multiplication x3k is equal to x1k into x2k. Sorry, this is multiplication will be point by point. Yeah, these two sequences are multiplied in frequency domain. Multiplication will be point by point. 10 multiplied by 10 multiplied by 6, 60. 0 multiplied by this 0. Minus 2 multiplied by minus 2 plus 4. And 0 multiplied by this 0. So multiplication will be 60, 0, 4, 0. One. 60, 0, 4, 0. Then the inverse DFT of this quantity will give you the circular convolution of these sequences. Means x3 n will be n point DFT of x3k. Means IDFT of this will give the circular convolution of these two sequences. Multiplication in time domain is equivalent to circular convolution in frequency domain. Let us do this in the matrix form. So x3n will be 1 upon n wn inverse DFT minus j1 minus 1 j. This is 1 minus 1 1 minus 1 1 j minus 1 minus j, and the conjugate of this into xk. x30, x31, x32, x33, and this is your small x30, small x31, small x32, small x33. So can you find this? What is the value of x3n? 1 by 4. This matrix will be is conjugated. J is replaced by minus j. J is replaced by 1 j minus 1 minus j, 1 minus 1 1 minus 1 1 minus j minus 1 and j into this is 60 0 4 0. Can you find this, the value of x30, x31, x32, x33? Can you find this? This is 60 plus 4, 64. This is 160 plus 0,
56.
56. This is again 60 plus 4, 64. This is 56. 1 by 4 means all the quantities are divided by 4. This is 16 14, 16, 14. So x3n will be 16, 14, 16, 14. This is your circular convolution using DFT and IDFT. So in the exam, either question will come, find the circular convolution of two sequences. Then you can take any method, either in time domain method or frequency domain method. But if it is specified that find the circular convolution of these two sequences using DFT and IDFT, in that case, you first find DFT of first sequence, then you find the DFT of second sequence, then multiply these two and find the convolution of these two. Oh, find multiply, then again IDFT of these DFT multiplication will give you the circular convolution of these two sequences. Is this okay?
Yes, sir.
Yes, sir.
Anyone, if you want, I can do one more example. Do you require one more example? No, not required. Okay. Then I am giving you one. Oh, someone written has yes. Let us have one more example. Find the 4-point circular convolution of the sequences x1 and n is equal to 0, 1, 2, 3 and x2 n is equal to 1, 1, 0, 0. To find the 4-point circular convolution of these two sequences. So let us take formula. x3m is equal to sigma n is equal to 0 to n minus 1. Since the convolution is 4-point circular convolution, n is equal to 4 to 0 to 3, x1n, x2 of m minus n modulo 4. Means for m is equal to 0, this is x3 0 is equal to sigma n is equal to 0 to 3, x1n, x2 of minus n modulo 4. So let us draw x1n and x2 of minus n in the circle. So if this is your circle, x1n, this is your positive direction, 0 starts from here. So we have 0, 1, 2, 3. Similarly, what is x2 of minus n modulo 4? For drawing the s2 of minus n, we put data in the reverse direction and read in positive direction. Means the second is 1, 1, 0, 0. Means this is 1, 1, 0, 0. Then x2 of minus n modulo 4 is 1, 0, 0, 1. So what is the value of x3 0? Yes. 1 into 0, 0, 1 into 0, 0, 2 into 0, 0, 3 into 1, 3. So x3 of 0 is 3 here. Similarly, for m is equal to 1, what we do? x1 and x2 of 1 minus n modulo 4 means this x2 of minus n is again shifted by one unit and multiplied by this. So let us shift this again by 1 unit. This is your positive direction. x2 of 1 minus n modulo 4. So for one shifting, this one is shifted to this one is this is here, this comes to here, shifted by 1 unit means 1 comes to here, 1 comes to here, this 0 comes to here, this 0 comes to here, and 0 comes to here again. So what is the x3 and x3 value?
1.
0 multiplied by 1, 0, 1 multiplied by 1, 2 multiplied by 0, 3 multiplied by it is 1. Similarly, what is the value of x3 2? Sigma n is equal to 0 to 3, x1 and x2 of 2 minus n modulo 4 is again shifted by 1 unit, x2 of 2 minus n modulo 4. So this is again shifted by 1 unit. This 1 comes to here, this comes to here, this comes to here. It is 0 comes to here, 1 comes to here, this 1 comes to here, 0 again comes to here. So what is the value of x3 2? This multiplied by
3. 3.
This multiplied by this is your x1 and positive direction 0 1 2 3. So 0 into 0 0 1, 1 into 1 1, 2 into 1 2, this 3. What is the value of x3 3? Sigma n is equal to 0 to 3, x1 and x2 of 3 minus n modulo 4 means this is again shifted by 1 unit. So let us shift it by 1 again by 1 unit, x2 of 3 minus n modulo 4. Then this 1 comes to here, this 1 comes to here, this is 0, this is 0 direction. So what is x3 3? 0 plus 0 plus 2 plus 3 is 5. Is it right?
Yes, sir.
So
Yes,
then
sir.
x3n will be, first quantity is 3, second is 1, third is 3, fourth is 5. First quantity is 3 1 3 5, 3 1 3 5. This is the time domain approach. In the frequency domain approach, we first find x1k, then we find x2k, then multiply x1k into x2k, and then again IDFT will give you the same answer. Kindly do it in your home. The convolution of these two sequences in by DFT and IDFT. This is all about today's classes.